Hello there, and welcome back to this third tutorial of the curvature correction of tutorial 12, sorry. So this one, we're going to work in a vortex generator. So the concept is very similar to a swirling flow, but here we're talking about concentrated vortex and something that you find very common in aeronautical applications. Okay, so let's introduce the case. Let's see what we have. So basically the idea is these vortex generators that you have here. Okay, so we're not going to simulate the whole airplane or the whole wing, just a small segment, but this one is going to generate a very concentrated vortex, and they have the influence in boundary layer. By the way, you have this also in cars. Okay, it's not only limited to airplanes. So this is a demonstration case. We don't have any validation data. However, we know what should be the behavior. Okay, so this is what we have. We have this mesh, okay, and this small domain. So see that we have this vein here that we put it here, and the flow, the incoming flow with here, and then it's going to generate that concentrated vortex. So these are our results, and see that we're comparing here Reynolds stress model with different turbulence models, eddy viscosity models with no curvature corrections, and see how different is the behavior. Okay, very different behavior between all of them. And let's say for what we know about the physics, this should be the kind of the true behavior. Okay, so a very concentrated long vortex. However, these models are under predicting this. But now what happened when we enabled these corrections? See that much better results. And by the way, see that the Spallar armadas is giving very good results, very good agreement with the Reynolds stress. It's a very good model for this kind of applications, external aerodynamics. And see that you just enable this one, and very similar to Reynolds stress. K omega, okay, SST, it approached to these two models, but it's still a little bit more diffuse. And again, here the K epsilon realizable is not giving good results. Okay, so in this case, it might not be the turbulence model of choice. And basically, I have to say all of the K epsilon family models will not give satisfactory results here. Okay, again, Spallar armadas, very good behavior, very economical model, specifically formulated for this kind of applications. Okay, so this is what we're going to study. Okay, we know what we should expect here, and the only thing that we need to do here is enable or disable that curvature correction. A few additional plots and planes just to show you velocity. Okay, so see that even if you have that concentrated vortex here, see here that you have some velocity values, okay, that they're very similar. Okay, and then in this case just plotting or releasing the streamlines from the surface and plotting, see that you have there your vortex. So let's work in this case. Again, you download, you go to your folder case. Okay, you can download it and you will find the Fluent cases. Okay, so you have there a solution. I don't recall this case, is very economical. In my case, I have some solutions. Okay, but we can run it. We have the geometry, and also you have there the meshing settings. Okay, so feel free, you have the geometry, you can do your own mesh and test different test with wall resolvable and wall modeling meshes. I don't recall what kind of meshes this one, but we can check. So that's all for the case introduction. Thank you for your attention. See you during the case setup. Okay, thank you, bye.